Hello, my name is Christian Mara, and this is my video presentation for the final project, that being the Campus Network Packet Tracer. So the first thing I did before even really starting was I needed to calculate the subnets. And this is the main idea I used, or concept I used, in order to do this, which was each subnet needs enough address space for all hosts as well as the required network and broadcast addresses. So, the first task was to take the major network, that being 172.16.0.0/16, and divide it into 16 equal size subnets, and divide it into 16 equal size subnets. So, the second thing I needed to do from that was determine how many bits I need to borrow from the host portion. So for that, I used the formula number of subnets equal 2 to the power of n. In this case, n is the number of subnet bits. Since I needed 16 subnets, the equation was fairly simple, that being 2 to the power of 4 equals 16. So I needed 4 new subnet bits added to the /16 network. Adding 4 bits to the /16 network gives a new subnet mask of /20, which corresponds to 255.255.240.0. The block size for a /20 network is 16 in the third octet, meaning each subnet increases by 16 in the third octet. So, going 1 through 16, the first one being 172.16.0.0, the second one being 172.16.16, third being 172.16.32, and so on and so forth. Of course, every third going up by 16, meaning the next one be 48, 64, 80, 96, 112, 128, and so on and so forth. That meaning that the 16th would be 172.16.240.0. All of these use the /20 mask, so all of them use the 255.255.240.0 mask. Moving on. This assignment required using the first 5 of these subnets for the network, so the first one being the students/classrooms, the second one being for administration, the third being for faculty and staff, the third being faculty/staff, the fourth being for the server farm, and the fifth being used later for the VLSM. Next, I assigned the default gateway addresses. I chose a pretty standard convention, which was to use the first usable IP in each subnet as the default gateway. So, for example, the student subnet default gateway was 172.16.0.1, administration 172.16.16.1, faculty 172.116, faculty being 172.16.32.1, and the server farm being 172.16.48.1. In the server farm subnet, I also assign IPs to the servers, them being the DNS, the DHP, and the email. The DNS being 172.16.48.2, DHCP being 172.16.48.3, and the email server being 172.16.48.4. So this completed the fixed subnet addressing portion of the assignment. So moving on to the VLSM subnetting of the fifth subnet. The next major task was to take the fifth subnet, which is 172.16.64.0 using the /20 subnet mask, and to break it into small subnets using VLSM, which each small subnet supporting a maximum of 6 usable hosts. To determine the number of host bits needed, I went back on using a similar formula that and came up with usable host equals 2 to the power of h minus 2. And for H obviously being for the host. And for 6 hosts, we got 2 to the power of 8 minus 2 equals 6. So going from there, we get 3 host bits. Since an IPv4 address has a total of 32 bits, the new mask would equal to being the /32 minus 3 equals /29, which gives us the subnet mask of 255.255.255.248. So that's 255 3 times and then 0.240 at the end. So a 29 So a /29 has a block size of 8 in the 4th octet, meaning like before, the first 5 VLSM subnets would increase by 8 each time in the 4th octet. I'm just gonna list all 5 out real quick. So the first one being 172.16.64.0, second one being 172.16.64.8, and the third one being 172.16.64.16, the fourth one being 172.16.64.24, and the last one being 172.16.64.32. The assignment then required the first VLSM subnet to be used for the network core, which is where all the 5 routers connect. So, because 172.16.64.0 gives us 6 usable IPs, I assign each router's FA0/0 interface as follows. The campus entrance router being 172.16.64.1, students router being 172.16.64.2, administration router being 172.16.64.3, faculty router 172.16.64.4, and the server farm router being 172.16.64.5. So this completes the VLSM addressing. Moving on to host configuration. Next, I configure the host for each PC, following the same instructions for each. That being to go to the config tab, go to the fast Ethernet to enable the port, then enter the IP address, subnet mask, and default gateway for each, and then go to under the settings tab and then do the same for the DNS and the IP for the DNS server as well. Each client PC was given an address inside its appropriate /20 subnet, and I verified that the gateway and the DNS settings match the values calculated earlier. The routers were configured next. For each router, a similar procedure was followed. That was to open the router, go to the config, go to fast Ethernet 00, assign the correct /29 address, and enable the port, and then do the same for the fast Ethernet 1/0. So as a quick example, I'll just list off what I did for the student router. For the FA00, it was 172.16.64.2, and for the FA1/0, it was 172.16.0.1. For each router, I saved the configuration using the NVRAM save to ensure the settings persisted throughout the rest of the assignment. According to the assignment guidelines, the host should be able to ping each other and other devices within the same subnet. They should not yet be able to ping across subnets since routing protocols weren't configured. So I tested this using PC0. So I pinged it to PC1, which was successful. And I pinged it to the router, which was also successful. PC0 was unable to ping PC3 at this time, which was expected since inter-network routing isn't active yet. This verifies the addressing design is correct at this point. Moving on to the DHCP configuration. This was done by going to the DHCP server and turning the servers on, entering the default gateway, DNS server IP. Moving on to web servers and DNS. I next had to configure both the internal company web server and the external internet web server. So I went to config for each of the servers to HTTP, and the service was already on, but I went there just to ensure it was, and customized the message for each server. And for DNS configuration, I went to the DNS server and I enabled the DNS service. I created a DNS entry for the company web server. Finally, from any current computer, I attempted to open the web browser and test the URLs and test to see if the web page loads successfully, and that would confirm that the DNS entries were working correctly. So to talk real quick about some issues I had, trying to get the web pages to load successfully was very hard, and I ended up just kind of letting that be because I couldn't figure it out after like 2 hours of thinking. And the main thing for me was just memorizing all the different IP addresses, considering that there was a lot, and there's a lot of modifications done to different ones because I needed to be on different things. That was just really kind of a me thing, really. Other than that, the assignment was relatively fair. Sometimes I'd missed a number, or I put in the wrong number, and I have to go back and then figure out which number was for what, and then that was really tedious and time consuming. So that was really the only issues I had with that. So yeah, thanks for watching.